crisscross makes you wanna jump. So the reason that I put this first one on there was because algebra is the kicker that we found on yesterday's Warriors Got Pre-Calc Talent that was tripping people up. Okay, I think of like number 2. I think of that as an algebraic problem, and so in algebra, we saw a lot of people yesterday dividing both sides here by x. And that's not algebraically sound when you're solving. When you're solving, what you need to do is you need to get everything onto one side so that you have it equal to 0. So this would be 3x squared minus 2x equals 0. And then you factor. Okay? So here I would factor out an x. If I factor out an x, then I'm left with 3x minus 2. And that is equal to 0. Then once it's factored, then you can set your factors, each equal to 0, and solve each one of those. Giving you 2 answers here of 0 and 2/3. If you divide by x right off the start, you only get the 2/3, and so you only have half of your answers. Okay, so you're missing out on a factor. Another way to remember that is with the biggest exponent, the degree, if you will, of the equation is how many solutions you need to have. So in this particular case, we need 2 solutions, okay, because my degree is 2. Over here, I would first change this to 3 over the sine of x first. Then I would multiply the entire equation by sine of x to get rid of my fraction. When I do that, I get 3 minus sine squared of x equals negative 2 sine of x. Again, get everything onto one side. I'm a fan of positive squared terms, so I'm going to move everything to the right side. And that's going to give me 0. Here, let me move this down a little bit. That's going to give me 0 equals sine squared of x minus 2 sine of x minus 3. Then I have to factor sine of x minus 3 sine of x plus 1. Set each of those factors equal to 0. Sine of x minus 3 equals 0, so the sine of x equals 3. Sine of x plus 1 equals 0, so the sine of x equals negative 1. Can sine of x ever be 3? No, so that one is not possible. Can the sine of x ever be negative 1? Where? 3 pi over 2. So my answer here is just 3 pi's over 2. Questions, comments, concerns? been simplifying up to this point. Okay? And so we took these actually from last year's formative that we just had. Okay? When you are simplifying, you need to be clear in your thinking. Okay? You need to show what you're thinking. We can't assume anything. Okay? I saw a lot of this. And I saw a lot more of this right here. Okay? I have no idea what you're thinking in that. Because all of a sudden, randomly, you're multiplying the top by cosine squared. Okay? Now, if what you're trying to say here is tangent squared of x divided by secant squared of x is sine squared over cosine squared, and that's 1 over cosine squared, then you need to say that. Then in a separate step, you need to say that this then becomes, well, come on, there it goes. Then say that that is like that. Okay? A lot of people were trying to do, if there's 3 steps to do, they're skipping over step number 1, going right to step number 2, going right to the answer. Doesn't work anymore, especially starting today. Because today what we're going to do is we're going to say that this, so this was the problem right here, that this here is equal to sine squared of x. This is the problem today now. We're telling you that tangent squared of x divided by 1 plus tangent squared of x is equal to sine squared of x. You have to prove it. And in order to prove it, you have to show every single step. It's just like a geometric proof back when you were in geometry. You got to show every step along the way. Okay? Can't just skip over some. Can't just gloss over some like some of these other people were doing in years past. Okay? Okay? Got to show actual everything of what you're thinking. Okay? Let's jump into that then. Okay? So let's do it with an algebraic identity. Okay? So I'm telling you that x squared minus 1 divided by x minus 1 subtracted, and then minus x squared minus 1 over x squared plus 1, that is equal to 2. I'm telling you that right now. Flat out. I'm telling you that's equal to 2. Okay? To prove that, I am going to take the ugliest looking side. Okay? The meanest, the nastiest looking side, that's the side that I'm going to start with. Okay? So in this case, I'm going to start on the left side. The reason we do that is because we can do more with ugly. Okay? When you're pretty like me, there's not a lot that you can do. Okay? But when you're ugly like me, there's a lot that you can do to make me look pretty. Okay? See how I put up my foot down and put down my foot up? Balance. Okay? So I'm going to work just this left side. I'm going to ignore the whole equals 2 part. Okay? So, how I'm going to work this? Well, what do you want to do? What? we could common denominator it, okay? Or could we factor the tops? Right? Because now what can I do? On this left one, I can cross out the x minus 1's. On this right one, I can cross out the x plus 1's. And so then that leaves me with x plus 1 minus x minus 1. Which is x plus 1 minus x plus 1. Which is what? That's 2, right? And 2 is what I need it to be. So not only on these problems am I giving you a question, I'm also giving you the answer. And you have to keep going until you get the answer. You're not done until you get the left side equals the right side. So you're going to simplify one side until it's the other side. Okay. Now, your pink formula trig identity sheet is going to come in rather handy because you are going to only be able to work one side of the equation, and you're going to pick the more complicated side, and you cannot do something to both sides. Okay? So the only thing that you have to use is all of these identities, 1 through, I think we're through 17. Yep. All of these identities, 1 through 17. Okay? So let's do this particular one. Come on. There we go. Let's do one more right away. That way we can put it right up at the top. Okay? So it's either going to say verify, or it's going to say prove, or it's going to say show that this equation is true. Okay? And so you're going to take the most complicated side. Let's take a moment here to decide in this particular problem which side is more complicated. What do you think, Pete?
I don't know. Because secant, the cosecant are a little more but their multiplication.
Right.
Is there like a trick, like either multiplication or addition?
Which one do you think is more complicated?
Probably the secant, the cosecant.
Give you another chance.
The tangent, the cotangent.
Because if I'm thinking of tangent, if I'm thinking ahead, tangent is sine over cosine, correct? And cotangent is cosine over sine. So those have different denominators, which makes it more complicated because in order to combine them, I've got to get a common denominator. Yeah. Okay. Addition with trig, addition and subtraction is always more complicated than multiplication. Okay. So with that being said, we are going to look at the more complicated side, which is the left side. Okay? So I'm not going to touch the right side at all. It's going to stay secant, cosecant. Okay? So, first thing I do over here is what? What do you think first thing? What? Like how? No, but you had a full tangle in your mouth. I saw it in your eyes, though. Okay? Then what? Common denominator. What's my common denominator? Cosine of x. Sine of x is my common denominator. Left fraction becomes what? Sine squared on top. Right fraction becomes what? Cosine squared on top. Now I can combine the fractions, yes? Now what? We're both pink sheet. Top is 1 because top's the hammer. Oops, I think I'm cosine first. Yep. Agree with that step. That 1 over cosine sine is 1 over cosine times 1 over sine. Yeah? Okay? 1 over cosine is secant. 1 over sine is cosecant. And that, if we go back up, that's what we wanted. So we know we're done because we got what we wanted. And yes, you have to show all of those steps. Okay? I'm going to let you guys do this one, but I want you first to tell me which side is uglier, which side is more complicated. Left or right? Which one? I'd go left. Yeah, I'd go left side being more complicated on this one. Okay, go for it. All right. So, probably want to distribute in that sign, right? So then that would be like, if I distributed in there and into there, so then that's going to be sine of x times So the left fraction simplifies to be cosine of x. The right fraction simplifies to be sine squared of x. Yes? Good, Brennan?
Yeah, same. And I didn't get it, so.
I focused on the parentheses first.
Okay.
And then add the sine.
And then multiply by the sine at the end?
Yeah.
That's fine. What doesn't make any sense here?
How you,
Distributed sine?
distributed sign, and then the only place it came out was in front of us.
No. Came out here, it's in blue.
Oh.
Yeah.
But then why doesn't it go to tangent too?
Because there's not a plus sign in between the cosine and the tangent.
Cosine tangent is basically being treated like one term.
So I think of it as an algebraic type problem. Okay? So in my brain, I was thinking, so let's call sine of x, let's call that q. Okay? So I was thinking of q times m plus np. Right? Because they're all different. And so if I would distribute q in there, I would get qm plus qnp. Okay? I don't get qm times qn qp. Okay? Because I only got, that's one term. Terms, remember, are separated by addition and subtraction signs. Okay? I'm not even going to tell you which side's more complicated. I'm going to let you decide that, and I'm going to let you go for it. Talk to me. I don't care which side is more complicated. You tell me.
Left side.
Left side more complicated? Are we in agreement on that?
Yep.
Yes.
Okay? If we're not in agreement on that, then all of the steps that I do them in reverse. Okay? Did you know that? If you choose the other side, you do all the steps in reverse, and you get back to it. It's like there's one path going back and forth. Okay? Okay? So, left side is what we're going to go with. So I would say that tangent, tangent of x is sine of x over cosine of x. Anybody disagree with me on that? Good. I would say that secant of x is 1 over cosine of x. Agreed? So that tells me that I can add them together, right? Okay? So that gives me sine of x plus 1 over cosine of x. Right? Now what?
That's where I got it.
That's what you got?
Yeah.
So is that the other side, though?
No.
No, so we're not done. We can't just... I know. What's up? That I'm going backwards then. If I separate them, then I'm right back up to here, and then I go right back up to there. Why wouldn't I combine them in the first place? They're fractions with common denominators. I can add them. I know, but you can't because the minus on the other side. Ready for a helpful hint?
Yep.
These things are
Eyes.
eyeballs. Let's use them. Okay? Ready? Let's take a peek at the other side. What does the other side have that this blue fraction doesn't? Got one minus sign, right? Okay? So if I multiplied by 1 minus sine of x over 1 minus sine of x. Have I changed anything? Why not? Because I'm multiplying by 1. Haven't changed anything, right? Right? I can multiply by 1 and not change anything. So the top, if I multiply the top out, I'm going to throw a couple of parentheses around here. If I multiply the top out, what do I get? Couldn't have been. It wasn't the same there, kiddo. Can't do it. I can't stop until I got the answer. Right? Now what? What's 1 minus sine squared? Cosine squared. Now what? Get rid of a cosines, right? Can I get it? Can I get it? Can I get it? I can get it. We'll cut right through the middle. Yeah? Okay? So sometimes you can't use the other side when you're doing this, but you can take a peek at the other side and you can say, this is where I need to go. Let's bring this into play, kind of a deal.
It's kind of like going to Mosby's marathon.
Kinda. Yeah, but you still got to get to Mo's knee somehow. Okay? It's the season of love. So he gave you a math pickup line.
I wish I were. How do you even say that though? Sine squared?
I wish I were a sine squared.
You were cosine.
And you were cosine
So
squared.
together.
Because together we'd be 1. Get it? Cheesy pickup lines from the mathies.
It's like,
Woo! Do it! Left or right side, which one? Left? Okay, here we go. So, if I'm looking left, what are you thinking first? Change the top to tangent squared. Number 11 on your sheet. Oops, that should be a theta, not a weird looking thing. It's number 11, right? I think it's number 11. Number 11. Okay? Not number 9. Now what? No. Number 11. Secant squared minus 1 is tangent squared. So, number 11 on your sheet there, B, is right? So that means that you know what I mean? Yeah. Okay. So secant squared minus 1 is tangent squared. Love it. Then I would say that this is sine squared of theta divided by cosine squared of theta. Oops, that should be a squared, not a degree symbol. Divided by sine of theta. Dividing fractions, I multiply by the reciprocal. So this is sine squared of theta over cosine squared of theta times 1 over sine of theta. Which is sine of theta over cosine squared of theta. Cosine squared of theta is 1 minus sine squared of theta.
That was not simple.
That was what? Too simple?
That was not simple. Don't put words. And now,
I'll still give her a free high five.
I won't make you.
Okay? Oh, we still got time. Love it.
They all have the same base, so just
Prove it.
one. It's the hammer.
What now?
It's the hammer.
What do you mean it's the hammer?
Cosine squared times sine squared
Is not the hammer.
is one. It's plus. It's cosine plus.
The hammer, according to number 7 on your sheet, is plus, not times.
Good revelation. You're doing great. That's what my mom said.
Which side looks more complicated?
All right.
Left side, right? Left side is more complicated. Seriously.
The left side.
Multiplying with the same base, what do we do with the exponents? We add them. Then it's what? E to the first. Practice makes perfect. There are, I have posted some practice problems on out of your textbook on the It's Learning page. Okay? Nope, I'm just saying practice makes perfect.